Hey, I'm gonna just give a quick overview of this work assignment. You're gonna do all three sections, okay? The first one talks about positive, negative, or zero work. So we need to think about work. Work is a transfer of energy. If I want to add energy to the system, I apply, for instance, in that pendulum, I apply a force to the pendulum, right? And the pendulum swings higher. You can think of this like pushing a friend on a swing, or a niece or nephew or a younger brother or sister on a swing. When you apply a force over a distance, you're adding energy to the system and they swing higher. So that would be positive work. Other types of work is basically changing the amount of energy, so transferring energy out of the system. For instance, if I were to run into second base and I slide, that sliding, right, I go from a faster pace to a slower pace, my energy is decreasing, so that means it's a negative work, okay? Consider the situation. A moving book slows to a stop as it slides across the room. So as it slows, that means my kinetic energy is decreasing. It's level, so I don't have to worry about potential, but that means my energy is being transferred out of the system, I'll say negative work, and it's being transferred out by friction over that distance, right, like that, okay? So that's this section on work, positive, negative, or maybe there's zero work, okay? So we'll go to the main menu. Okay, gain or loss. Let's see what this is going on. Consider the situation. A softball player slows to a stop while sliding across the infield directly towards third base. So this is kind of a repeat situation. And in this situation, work is done on the softball player by what? The infield dirt pushing up on the player, the friction between the player and the infield dirt, the Earth's gravity pulling downward on the player, on the player's legs while she was running. Okay, that's clearly out. That sounds silly. But these three are all talking about the forces that we deal with. So we can picture that free body diagram. The force of gravity going down, the Earth's gravity, is that causing them to slow down? The normal force, right, which is the dirt pushing up on the player, and then the friction force. So that force is involved in slowing the person down, right? So if I'm running horizontally and there is a force in the opposite direction, I will decelerate, which means I'm slowing down, which means my kinetic energy is decreasing, so it's the friction. And then mechanical energy is decreasing. I check it, I'm good to go. So a two-part section on that one, okay? Go to the main menu, and we'll go to the last one, E, transformation or energy transformations. Work done on an object or system of objects causes a transformation of energy. Consider the following situation. A car with locked wheels skids to a stop while moving along a level highway. We keep kind of getting the same situation, but maybe this is good. This situation can be best described as a transformation of what? Kinetic energy into potential. Okay, I'm moving and then I'm not moving, but I'm not going up or down. Chemical energy, that would be the energy by the engine. Okay, that gas has potential energy. Once it's combusted, it turns into usable mechanical energy. So not chemical energy. Potential energy into chemical energy, not there. Chemical to kinetic, and then kinetic energy to dissipated energy, heat and sound. So what happens when your tires lock up, right? They get hot, they melt those tires, they provide those skid marks, and also a screech. Kinetic into dissipated energy, and that makes sense because my energy is not being conserved. I'm going from high kinetic energy to low kinetic energy, meaning energy must be transformed. Where's it going? It's transforming into heat and sound or dissipated energy. Okay, check answer. We're good to go. So there's gonna probably be some different scenarios, probably some things that are vertical, right? And you'll need to use your new understanding of energy to make your way through this. I hope that helps. Chime in anytime on a conference if you need some help or via email, okay? Talk to you later.